Welcome to Developing Graphics Frameworks with Python and OpenGL, Part 35, Extras, Movement Rig. We have some really interesting 3D scene creating capabilities at our disposal now. We can create all sorts of objects using some built-in geometric shapes and materials, and we recently learned how to create customized shapes and materials. But if we really want the scenes to be interactive, it'd be really helpful if we could move around the scenes. And this would be useful enough functionality that we should put it in its own class. So what we'll do is create a new class called Movement Rig that we can attach an object to and move it around the scene. And in this particular class, if we attach a camera to a movement rig, it will be as if we ourselves are moving around in the scene. Or we could attach the movement rig to an object within the scene and control it, kind of like a third-person controller. So this is the plan for the movement rig. We'd like a built-in control system with some default set of keys you can press to move around. We'd like to be able to move locally, forwards and backwards, left and right, all local translations. It'd also be nice to be able to turn left and right. And while we're at it, it would be nice to be able to look up and down, but not necessarily to turn up and down. What I mean by this is looking should change the angle at which we see the world, but look should not have effects on moving forwards, backwards, left, and right. Imagine if you were walking around a field, you can look up, but move forward and still be moving in that horizontal direction, right? We'd like this to be a very intuitive movement control schema, but we'd also like the ability to fly up and down. Right? In order to get a good perspective on our scenes, sometimes we'd like to view it from the top down. So we'd like to be able to fly up and look down in combination and move around. So this is the goal, to build a class which supports all of this kind of movement. All right, this is kind of some fun extra functionality. It's not really part of the core, and it's really not a geometry or material. So we're going to go ahead and add a new folder into our structure. Right up to this point, we have core geometry and material. These fun extra things, I'd like to create a folder called extras. So I'm going to right click on Python graphics and create a new folder. And I'll call this folder extras. And within this folder, make a new file. And I'm going to call this one movementrig.py. Right, and this is going to extend the 3D object class, object 3D, because transformation is going to be really the main focus of this class, which is part of the object 3D class. So from core.object3D, let's go ahead and import the class object 3D. All right, so this class is called movement rig. It extends an object 3D. And to initialize this object, we could give it some useful information. We could say, for instance, how fast it's going to move and rotate. So let's put those in as parameters, maybe units per second, set that equal to 1, and for rotating, degrees per second. It's intuitive to think in terms of degrees, I think. Now let's make that 60, so we can spin around in 6 seconds. All right, so first I need to initialize the base class. It sets up the transformation matrix. So we call super init function. And then, let's see, what we're going to do here. The trickiest part of this class is actually the looking up and down. We want look up and down to not affect the movement of kind of the base. And so we're actually going to use the scene graph framework structure to our advantage here. So what we'll do is we'll attach kind of, I'll think of this as a look attachment. We'll attach a 3D object to this 3D object, right? The base object that we're extending, that will be in charge of moving forwards, backwards, left, right, and turning. But we'll attach another 3D object to this class, and the attachment can look up and down. But since movement's applied to the base object 3D, looking up and down won't affect that core movement. Let's write some code. So I want to initialize some kind of a attached object. So attached object 3D. Right, so self dot, let's call this the look attachment. And this is going to be a new object 3D that we attach to this. Right, so self dot children. Right, the child is going to be the look attachment, self dot look attachment. And the parent of the look attachment is going to be this object, this itself. Now you might wonder, why don't I just use the add method? And the problem is we want the add method, we want to be able to add a camera or another object to this movement rig. Right? The object we attach to this needs to go into the look attachment, not this base self object. Right? So I'm going to actually need to redefine the add and remove functions in just a moment. And so I won't be able to use them to set this object up because I'm going to, well, redefine them. The other thing I want to do before I forget is to store these parameters in class variables or instance variables, so units per second and degrees per second. All right. So again, in order to add something here, right, if I try to use add on this, if I want to add a child, by default, the child would be added to self. What I'd like to do here is add to the look attachment. Right, so self.look attachment, add the child to that. So it's kind of, it's putting the child at the correct level. Okay, the next thing I'd like to do is to set up some key constants, right? Which keys are we going to use to move around the screen? And I'd like these to be customizable, so we'll actually define these in the initialization function. Right, so let's put in a comment, customizable key mappings. And some of these are kind of well-known standards. So for instance, self dot, let's say the key for moving forwards, right? It's very often the W key, right? And similarly, for moving backwards, left, and right, right, let's give these keys names, backwards, moving left, and moving right. And those are typically W, S, A, and D. And the reason for doing this, it kind of makes sense. Let's see if I can turn on my keyboard, right? W, right? W and S, they're arranged in kind of the same positions as the up and down key. And A and D are arranged in the same relative positions as the left and right key. So W, A, S, and D are very much like up, down, left, and right. So it kind of makes sense that you would use those keys. Let me remove these extra letters. Now for the other keys, I've thought a lot about this. Let's call self.key turn left, and we need a self.key turn right. And my thought on this is that you want this to be a mnemonic, so you don't have to be wondering which key is turn left and right. Since A and D are the keys, right, for moving left and right, let's make the keys for turning left and right be the keys directly above those. So since Q is above A, let's make Q the key for turning left. Since E is above D, let's make E the key for turning right. And so I'll call the left turn key, let's make that Q, and the right turn key, let's make that E. And then I need to be able to fly up and fly down. Right, so let's say key move up and self.key move down. You need to pick keys for this. I'd like everything to stay kind of close together. So the keys I like to use for this, well, since I'm already using Q, W, E, A, S, and D, R and F are right next to those. So since R is on top, I'll use that one for moving up, and F is right below that, we'll use that one for moving down. I like to use the mnemonic R is for rise and F is for fall. So rise and fall. Finally, we need some keys for looking up and a key for looking down. And I really like the mnemonic for turning, right? Just like A and D are moving left and right, Q and E are turning left and right, just as R and F are flying up and down, let's make T and G the keys for looking up and down. The mnemonic I like to use here is T. It's like looking up at a tower, and G is looking down at the ground. And so they're the things that you would look at. So T for looking up and G for looking down. Right, so W, S, A, D, Q, E, R, F, T, G. All right, so those are going to be my default key mappings. And then we just have, well, a bunch of different keys that we need to use to activate the different methods. Right, so we're going to set up an update method, I think, next. Right, so after the add method, and for a while, I can turn off my keyboard viewer. Let's add an update method to this object. It's going to take in a couple of things, an input object and delta time. So the input object, this is actually going to be the input class that we created a long time ago. Then we added it to base and we stopped thinking about it altogether. We will allow this class to query the input object to see if certain keys, the ones defined by these constants, are currently pressed. And if so, to apply the correct transformation to the object. Delta time is used to figure out how much you should move or turn or look in any given direction. All right, so to begin, let's create two variables, move amount. We'll calculate how much you should move based on the speed that we set times how much time has elapsed. The rotate amount, right, this will be applied for both looking and turning. Right, this is going to be degrees per second, which we need to calculate in terms of radians. So we'll multiply that by pi divided by 180. And then delta time. All right, now we just basically have a whole bunch of if statements. Now it's going to look pretty much the same, so I'll write one and then do some copy-paste magic. In each case, we're going to take a look at the input object and see if a certain key is pressed. For example, if key move forwards is pressed, then what do you want to do? Well, you want to move forwards. Forwards is along the negative z direction. And so we're going to translate by 0, 0, negative move amount. All right. And I'm going to copy that a total of 6 times for each of the different directions. All right, so for moving backwards, for moving left, for moving right, for moving up, and for moving down. In each case, I just have to adjust the translation. Moving backwards, we'll move by a positive amount in the z direction. Moving to the left, that's a negative amount in the x direction. Moving to the right is a positive amount in the x direction. Moving up is a positive amount in the y direction. And moving down is a negative amount in the y direction. And notice that translation is being applied to self, kind of the base object. All right, once we've got those, now we need to take a look at turning. And it's going to be kind of the same. In this case, if it's key, not key move forwards, but key turn left, right? In that case, we're going to, instead of translate, right, we're going to rotate around the y-axis. So let's do rotate y by some amount, rotating to the left by whatever rotate amount we calculated earlier. And then, if we're turning right, is key pressed, key turn right, we're going to rotate by a negative amount. And then finally, I need to take care of looking up and down. And we do those transformations on the look attachment we added to this object. Again, that's so it doesn't interfere with the movements of the base object. So, once again, let's go ahead and paste that in. This is going to be key look up. And in this case, not self, but self look attachment. Looking up, that's going to be rotating around the x-axis, which goes kind of from left to right in front of the object. So we're going to rotate x by whatever that rotate amount is. And similarly, if we press the key for looking down, then we're going to rotate down around the x-axis by that amount. Fantastic. So, hey, we've got all the code that we're going to need here for the movement rig. Let's go ahead and save this. Now, we'd like to go ahead and add this to an application. Right, so do we have any good applications hanging out we could just kind of copy here? Let's see, what about test 33? What did we do in that? Cool, test 33 was a spinning pyramid. That'll do. I'm going to go ahead and make a new example, and I'm going to call it test 35, and I'm going to copy the code from test 33 in there. Really, you can use any scene for this code, though. So in the Python graphics in my main folder, I'm going to add a new file. We'll save it as test35.py. I'm going to take the code from test 33, select it all, copy, and paste it in. And I'll comment out the line of code where it rotates. I'd like that pyramid to kind of stay fixed. Very nice. So now if I run test 35, I should just see a not rotating object. Excellent, just what I was hoping to see. Next, we're going to add a movement rig object to this class. So up in the top, the import statements, let's go ahead and say from extras.movementRig import movement rig. All right, and in this case, what we're going to do is we're going to create it right after we create the camera. I'm no longer going to pull the camera towards the viewer. We're not going to need to do that anymore. I'm going to say self.rig is equal to a movement rig object. Right, self.rig. I'm going to add self.camera to that. So the movement rig will control the camera. The next step is to make sure we add the rig to the scene. So self.scene. We'll add self.rig to that. And then the camera, we don't want to set the position of the camera, we want to set the position of the rig. Right, if we set the position of the camera within the rig, it's going to be a little bit complicated to control. Right, so we've added the camera to the rig, we've added the rig to the scene, and we've set the position. The last thing we have to do is make sure the rig auto-updates. So for that, we'll go down to the update class. We'll say self.rig.update. We might remember it needs some information. It needs access to our input object. So self.input. It needs to know how much time has passed. If we're getting 60 frames per second, that means delta time. Time per frame is 1/60th of a second. Let's see if this works. Let's go ahead and give this a run. Oh, inconsistent use of tabs and spaces. I hate it when I do that, but I seem to do it a lot. All right, so, but again, this is very helpful that Sublime Text helps us deal with that. Right, so under View, Indentation, convert indentation to spaces. I'll save that movement rig file again and try to rebuild test 35. And have we got it? So far, so good. Let me turn on my keyboard layout so you can see what I'm pressing. All right, let's try moving forwards. All right, pressing W, move forwards, S to move back, A to move myself to the left, D to move myself to the right, R to fly up, F to fly down. I can see that there's no bottom on that. That's fine. I can also press Q to turn left and E to turn right. And if I've turned, and if I turn and then move forward, I'm now moving that direction. But also I can look up and look down. All right, so if I wanted to see that pyramid from the top, I can go forward and fly up in the air and then turn myself down. Right, so I can kind of see what it looks like from above. And that gives us a whole new way to check out these three-dimensional scenes. And so now I'm just kind of sliding, moving to the right and turning as I do that, as you can see from the keys that I'm pressing. After a while, hopefully this will become as intuitive as WASD controls. Maybe that'll catch on sometime. But fantastic. That gives us a new way to move around our scene. Now, one thing which would help is if there is some way to kind of orient ourselves in the scene. So we're going to add a couple more extra objects in the next video. We'll learn how to add grids to give us an idea or sense of scale, and also axes, so we get a sense of orientation as to where we are within a scene. All right, but that's it for this video. The movement rig is a very useful addition to our graphics framework. Thanks for watching.